Let's recap the concepts of AP and GP. So we know that an arithmetic progression is a number series where consecutive terms or the consecutive numbers have a common difference. So some examples of AP are mentioned over here. First one, let's say we have the series 5, 5, 5 and 5, and it goes on. Now you might think that the number is the same, but if I look at the difference between consecutive numbers, we have 5 minus 5, which is 0, and again 5 minus 5, 0, 5 minus 5, 0. So the common difference here is 0. So even this becomes an AP. So the common difference, we write it as D. In this example, it is 0. In the second AP, we have the numbers 5, 8, 11, 14. So the difference between consecutive terms, 8 minus 5 is 3, 11 minus 8 is also 3, 14 minus 11 is also 3. So the common difference D is equal to 3. Now in the third AP, we have the numbers 5, 2, minus 1 and minus 4. If I again look at the difference between the consecutive numbers, we have 2 minus 5, which is minus 3, minus 1 minus 2 is also minus 3, minus 4 minus of minus 1 is also minus 3. So in the third example, the common difference D is minus 3. And on the right side, there are some examples of number series which are not an AP. So suppose we have the numbers 5, 6, 8, 11. 6 minus 5 is 1. 8 minus 6 is 2. 11 minus 8 is 3. So there does not exist a common difference, so it is not a AP. In the second example, 5, 4, 6 and 3, the difference between the consecutive terms, 4 minus 5 is minus 1, 6 minus 4 is minus 2, or 6 minus 4 is 2. So again, there is no common difference, it is not a AP. And the third example, 5, 10, 20, 40, the difference 10 minus 5 is 5, 20 minus 10 is 10, 40 minus 20 is 20. So again, there is no common difference, but then later we will see it is another kind of a progression, but it's not an AP. Okay, now let's look at what is the general term or the nth term of an AP. So suppose if I want to find out for a given AP what is the 10th term, 13th term, 100th term and so on, I need not list all the terms of the AP to reach that term. I can in general have a formula and then find the required term of the AP. So suppose if my given AP in general is A, A2, A3 up to AN. So these are the first term A, second term A2, third term A3 up to the nth term AN. And we know that if this is an AP, the common difference is obtained by subtracting the consecutive terms. So if I do the second term minus the first term, A2 minus A, that should be equal to the third term minus the second term, and so on, and that I can say it is the common difference D. So then if I look at A2 minus A, the second term minus first term, it's the common difference. So I can say that the second term will be A2 will be A plus D. In the same way, if I look at the third term minus the second term is also the common difference, and if I write down, I will find that the third term A3 is equal to A plus 2D. So when the first term is A, second term is A plus D, third term is A plus 2D, fourth term similarly will be A plus 3D, fifth term will be A plus 4D. So if I extend this, in general, any nth term should be A plus n minus 1 into D. So this is the general formula for finding the nth term. An, the nth term, is equal to A plus 1 less than n, that is n minus 1, multiplied by the common difference D. So as an example, here suppose the AP is 5, 8, 11, 14. How do we find the 15th term of the AP? So I will list down the known information. First term A is equal to 5. The common difference D is, let's say, 8 minus 5 or 11 minus 8, whichever way. Common difference is 3. We are supposed to find the 15th term, so the n value is 15. Then if I plug in these values in the formula, I get the 15th term as equal to 47. Next, suppose I want to find out what is the sum of the first n terms of an AP. So again, there is a general formula, and the way that it is derived is written down here. So let's say that the sum of n terms will be the first term A plus the second term A2 plus the third term plus the fourth term till the term before the last term, which is a n minus 1, and the last term, which is a n, or the nth term. If I add all of these, I get the sum, which is Sn, sum of n terms. Now this same sum, suppose I can write in the reverse way. I can first write the last term, which was an, and the formula is a plus n minus 1 into d. So this is the last term, and the term before the last term will be a plus n minus 2 into d, like that. Then I can write up to the second term a plus d plus the first term a. So the entire AP is written in the reverse way, but the sum will still be the same. Now if I add all the first equation and the second equation, then I will get sum of n terms plus sum of n terms, which is 2 times the sum of n terms. That is equal to, I will get a plus n minus 1 into d, which is 2a plus n minus 1 into d. And the same way, if I look at adding up all the terms which are now in this form, so the second terms were a plus d plus a plus n minus 2 into d. If you simplify that, it will again be 2a plus n minus 1 into d. So adding up all these terms will give me 2a plus n minus 1 into d. 2a plus n minus 1 into d. So 2 times the sum of n terms is 2a plus n minus 1 into d when I'm adding it for n number of times. So this addition of n number of times I can convert to multiplication by saying that the sum, which is 2a plus n minus 1 into d, 2a plus n minus 1 into d for n times, it is same as n multiplied by 2a plus n minus 1 into d. So then the sum of n terms, Sn, will be equal to, if I move this 2 to the other side, n by 2 into 2a plus n minus 1 into d. So this can be directly used whenever we want to find the sum of n terms. Also, if I plug in the nth term formula, let's say I know that the nth term an is same as a plus n minus 1 into d, I can write the same formula for sum of n terms as Sn equals to n by 2 multiplied by a plus an. So a plus an represents first term plus the nth term, or the last term. The last term can also be written with the variable L. So as an example, let's say that the question is find the sum of the first 15 terms of the AP 5, 8, 11, 14, so on. So again, the first term A is 5, common difference is 3, number of terms is 15. Then I plug in these values in the formula, and I will find that the sum of the 15 terms is 390. So this, I was using this format, n by 2 into 2a plus n minus 1 into d. Otherwise, if I can find the 15th term first by using the general term formula, nth term formula, I will find that the 15th term is 47. Then the sum is also n by 2 into a plus an. So if I use that also, I get the same answer, which is 390. Now let's move ahead to geometric progression. GP is a number series where the consecutive terms have a common ratio. So ratio is when I take, let's say, the second term divided by the first term, or the third term divided by the second term. That ratio, if it is the same throughout all the terms in the series, that becomes a geometric progression. So I have taken some examples of GP. Let's say the first one. Again, we have just the numbers 5, 5, 5, 5 repeating like that. Now, if I see the second term divided by the first term, 5 divided by 5 is equal to 1. So this is happening throughout the series. So it has a common ratio. We call it R. and in this case it is equal to 1. Now in the second series 5, 10, 20, 40, if I look at 10 divided by 5, it is 2. 20 divided by 10 is also 2. 40 divided by 20 is also 2. So I will say that the second series has a common ratio 2. It's a GP with common ratio 2. Then for the third series, the second term divided by the first term is 1 by 5. Even the third term divided by the second term is 1 by 5. Same with the fourth term divided by the third term. So here I will say the common ratio is 1 by 5. Now I have also written a fourth series where the numbers are 5, minus 10, 20, minus 40 and so on. So I have alternative positive and negative terms, but even this is an example of a GP where suppose if I do second term is minus 10 divided by 5 is minus 2. The third term 20 divided by minus 10 is also minus 2. Minus 40 divided by 20 is also minus 2. So here the common ratio R is minus 2. So common ratio can be 1, more than 1, less than 1, or even a negative number. Alright, now some examples of series which are not a GP. Let's say the first one is 5, 10, 15, 20. Here 10 by 5 is 2, but 15 by 10 is not 2. So there is no common ratio, it's not a GP. Rather, this becomes a AP because it has a common difference of 5. Then the second one, 10 by 5 is 2, 50 by 10 is 5. So again, there is no common ratio, it's not a GP. Then the third series, minus 10 by 5 is minus 2, but minus 20 by minus 10 is plus 2. So again, there is no common ratio, so it is not a GP. Then we have a formula to find the general term or the nth term of a GP. Now let's say that the given GP in general is A, A2, A3 up to AN. So we have the first term, second term, third term till the nth term. Now the way we define common ratio, it is A2 by A, second term by first term, or even the third term divided by the second term, and so on, and all of them are equal to the common ratio R. So if I take the second term by first term, A2 by A is equal to R, then the second term A2 can be written as AR. A is the first term. So if I multiply the common ratio to the first term, we get the second term. And in the similar way, I can look at the third term, which is equal to AR square. So the second term is AR, third term is AR square, fourth term is AR cube, fifth term is AR to the power 4. So if I extend it, in general, any nth term, AN will be equal to A multiplied by R to the power n minus 1. So this is the nth term or the general term of a GP. So for example, if I wanted to find the 10th term of the GP, 2, 4, 8, 16 and so on, the first term is 2, the common ratio 4 divided by 2 is 2, and we have to find the 10th term, so n value is 10. So if I use the nth term formula, I will get the 10th term as 1024. Alright, then the last thing is again the sum of n terms of a GP. So again, if I just write down the sum of all the n terms, first term plus second term plus third term up to the nth term, and then apply the nth term formula to each of the terms. So let's say the first term is A, second term is AR, third term is AR square, up to the last term A R to the power n minus 1. So this is sum of n terms. Now if to this equation I multiply R on both the sides, so I will have R times the sum of n terms equal to AR plus AR square, like that, AR square, AR cube, like that if I write down. Then suppose this is my second equation, this is my second equation, and this is my first equation. If I do a subtraction, equation 1 minus equation 2, then I will get something like this. I will get sum of n terms, Sn minus R times of Sn is equal to A minus a r to the power n, because all the in between terms will cancel each other out. For example, this ar and this ar, this will cancel each other out, ar square will cancel each other out, and so on up till a r to the power n minus 1. These will cancel each other out, but only thing that will remain is the first term a minus a r to the power n. So this will remain. Then I can take Sn common. So Sn into 1 minus r equals to a multiplied by 1 minus r to the power n, and therefore one formula for the sum of n terms, Sn, can be written as a multiplied by 1 minus r to the power n whole divided by 1 minus r. Now it is also same as writing Sn is equal to a multiplied by r to the power n minus 1 divided by r minus 1, because from these two terms 1 minus r to the power n and 1 minus r, if I take minus 1 common, then it is the same as r to the power n minus 1 divided by r minus 1. In your textbooks you might see that depending upon the absolute value of r, if it is more than 1 or less than 1, you should use one of these formula, but technically both are the same. Now in this special case where r equals to 1, I cannot apply any one of the previous formulas, because then I will get 1 minus r, 1 minus 1 as 0. I cannot do a division with 0, so that formula is not applicable. But if you think logically, if r equals to 1, then all the terms in the GP are the same. So the first term, if it is a, then all the terms are same as a. So we will have the sum of a plus a plus a plus a, and in total we have n terms. So the sum will be n times of a, or na. That is when r equals to 1. But if r is not 1, any other value, I can use any one of these formulas. Also, sometimes in case the last term or the nth term of the GP is known and I want to find the sum of n terms, I don't know exactly what is n, how many terms do we have in the GP, but I know what is the first term, I know what is the common ratio, and I also know the last term of the GP. Then I can use a formula like this. The sum of n terms will be a minus L into r divided by 1 minus r, where a is the last term or the nth term of the GP, and it is also same as LR minus a divided by r minus 1. Both the formulas are the same. You can use it in that situation. Now as an example, suppose if the question is to find the sum of the first n terms of the GP, which is 2, 4, 8, 16, then I will see that the first term is 2, common ratio is 2, and the n is 10. Then I can use either of these two formulas. It's the same, like I have told you. If you plug in the values, you will get the final answer as 2046.